Good afternoon. We are going to do 4.3 part 2. We're going to add one congruence theorem to postulate to our list of triangle congruence postulates. This is angle, side, angle. Here we go. If two angles and the included side, meaning the side in between, of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. Okay, so look at this picture here. We've got A and X are congruent, so angle A congruent to angle X. Side AB and XY are congruent to each other, and angle B and Y are congruent to each other. So we have an angle, a side that's included, and an angle. Therefore, triangle ABC is congruent to triangle XYZ by the reason of angle, side, angle. We like the abbreviation too. That's nice to have. Okay, example 1. Are the triangles congruent? If so, give a congruency statement. Okay, so looking at these two triangles, right now all we've got is an angle. That's it. Right away, though, I hope you notice that they share a side right here. So we can say that side RQ is congruent to side RQ because of reflexive property. Reflexive property of congruence. So now we have an angle and a side. And here's where we're going to use what we know about parallel lines cut by a transversal. We have PQ and RS are the parallels, and they are being cut by a transversal. And one thing we know is that alternate interior angles have to be congruent. So we can say angle PQR is congruent to angle SRQ because alternate interior angles are congruent. So now we have an angle, a side, and an angle. We're ready for our statement, which is triangle PQR is congruent to triangle SRQ for the reason of angle, side, angle. See how that pulls together everything we've been learning? Reflexive property, parallel lines cut by a transversal. Great problem. Okay, flip the page. All right, example 2. Triangle XYZ is congruent to triangle QRS. Find the length of the sides of QRS. So we're looking for the lengths of the sides. Now, because we know that the two triangles are congruent, we know that corresponding sides have to be equal to each other. That's what congruent means. So let's start with XZ right here. XZ has to be congruent to QS. So I can say 3B minus 2 has to be equal to 2B plus 1. And thankfully this is solvable. So subtract 2B over to the left, add 2 over to the right, and you get B equals 3. What does that get us? Well, we're trying to find the sides of QRS. So QS is 2B plus 1. So 2 times 3 plus 1, that's 6 plus 1, or 7. So QS has a length of 7. Okay, there's our first one. Now let's do the bottom edges. ZY and SR have to be congruent to each other. So I can take 4A minus 2 and set it equal to 2A plus 2. CPCTC. Corresponding parts of congruent triangles are congruent. All right, let's solve for A. So subtract 2A over to the left, add 2 over to the right. 4 minus 2 is 2A equals 4. So A must be 2. Now that we've got A, we can get side SR. Side SR is 2 times A, which is 2, plus 2. 4 plus 2 is 6. So SR equals 6. All right, now the last one. Side XY and side QR are congruent to each other. So I can take 6C minus 2, set it equal to 3C plus 4. That's our equation. And solve for C. So subtract 3C over to the left, add 2 over to the right. 6 minus 3 is 3C equals 6. So C must be a 2. Now that we have C, we can find the length of side QR, which is 3C plus 4. So 3 times 2 plus 4. 6 plus 4 is 10. QR equals 10. And all of these are possible because we knew the triangles were congruent and corresponding parts of congruent triangles are congruent. That's it for today. Have a good afternoon.